Hello, everyone. Here we go with your introduction to proofs. Okay. Didn't put that in the title, but that's what we're doing. All right. So reasoning with algebra, we're reasoning through some problems. That's kind of what proofs are. Now, a proof is a mathematical argument that lays out step by step how to get from a starting point to an ending point. Now, a lot of times the starting point is the hypothesis. So my conditional statement, the if part, that's where you start. And then you conclude or end with another statement. So a proof gets me from the hypothesis to the conclusion step by step. Proofs are typically shown, at least in this class, as two-column proofs. You'll see some of those on the back. All right, but they could also be flow proofs. We will do some of those, but that's not till unit 4. And even paragraph proofs. Okay, I don't use those very often, but they can be paragraph proofs. Okay, each step in a proof must be justified. How do you justify one? Well, it uses previously learned definitions, postulates, theorems, properties, and more. This is why you must know these things as I'm teaching them, okay? Because you could use them in proof, and that's going to happen. We're going to go through units 1, 2, and 3, and we're going to be building a lot of theorems, a lot of properties, a lot of things like that that we then use in our proofs. Okay, so here we go. These are not proofs. These are some more properties. Now, when I say that, that means that these could be, or let me back that up. When I say that these are properties, I'm saying that these are potential reasons in my proof. Okay, so I'll talk about that. That probably doesn't make much sense right now, but these are potential reasons. Write that down, and we'll come back to that later. So what are these properties? Addition property. If two numbers are equal, if A equals B, and I add a number to both sides, so a random number C, if I add it to both sides, then they're still equal. That's all the addition property says. Subtraction property is very, very similar. Instead of adding a random number, though, I'm going to subtract a number from both sides. The multiplication property is, again, very similar. If I multiply a number by both sides, it stays equal. And the last one, division, not the last one, but the fourth one, if A divides by C and B divides by C, then they're still equal as long as, and you want to catch note of that, C does not equal 0. Why do we have to make that claim? Well, you can't divide by 0, so dividing by 0 would not allow the division property to work. Okay. The reflexive property for now is going to seem just silly. Okay, I'm going to tell you that it's going to seem just very silly. So what it says is if I have a number, it's equal to itself. Well, duh, right? Now, the next few change from equality to congruence. I don't make a big distinction with these, meaning if you put A plus C is congruent to B plus C, I'm going to probably not count you off. I know some teachers do, and there is a slight difference, but I'm not too worried about it at this point. Okay, so I do want you to see, though, that it changes from equals to congruence. So if A is congruent to B, then B is congruent to A. So what that's saying is if I don't know, 2x plus 5 equals 12, then I can flip that around and say 12 equals 2x plus 5. I can swap the two sides. That's the symmetric property. The transitive property says if A is congruent to B and B is congruent to C, then I can conclude that the first one is congruent to the last one. The substitution property, a lot of times can be confused with the transitive property, but substitution property says if A equals B, if those two things are equal, then B can replace A in any expression. You saw that in Algebra 1, right? Last one, distributive property, you should know this one. A parentheses B plus C equals AB plus AC. Okay, that one you know. Okay, now what we're going to do is name the property being shown or use the property given in parentheses to complete the statement. So this was, again, we're getting closer to proofs, still not quite there. So what I'm trying to have you see is, okay, I'm starting with this statement and I'm ending with this statement. What property allows me to make that step? Well, what did I do? So what happened from the beginning to the end? Well, the 4, nothing changed with the 4. What I did was I moved the X to the other side. Now, what did I do with that X to move it to the other side? I subtracted it from both sides, right? So when I subtract a number from both sides, what I'm doing is the subtraction property. Okay, and I will put property at the end. Okay, the next one, number 2, is saying I want you to do substitution. I'm telling you the property I want you to use. Now use it to make the conclusion. All right, so number 2 says if M equals 2n minus 5 and M plus n equals 16, well, then a substitution says if two things are equal, then I can put this second thing in for the first thing wherever I see it. So my conclusion would be instead of M plus n equals 16, I would say 2n minus 5 plus n equals 16. I replaced the M with 2n minus 5. The next one is a transitive property. I want you to use a transitive property. If angle P is congruent to angle Q, and angle Q is congruent to angle R, and angle R is congruent to angle S, what can I conclude? Well, the first one, angle P, is congruent to the last one, angle S. Now you might be like, well, there was only 2 parts in the transitive property above. It doesn't matter. I could keep going. I could go on forever and keep saying, and then angle S is congruent to angle T, and angle T is congruent to angle U, blah, 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 and I keep going. It's still the first one is equal to or congruent to the last one. Now the last number 4 here on the front, a lot of people mess this up. I think a lot of people are going to say distributive property. Okay. That might be what you would do. I want you to understand, I'm not asking what you would do. I'm asking what was done. So you need to look at this from here to here. What was done? Well, I didn't even distribute the 2, so that's not the distributive property. What moved was the 8. The 8 is gone, right? Where did it go? Well, look at the 3 became a 24, right? How did that happen? Well, what I did was I multiplied both sides by 8. What allows me to do that? Allows me to multiply both sides by a number? Well, that's the multiplication property. And that's the hard thing for students to see is it's not what you would do, it's what was done, okay? Identifying what is being done, okay? Let's go to the back. This is a proof. Now it's a very, very simple proof that you know how to do, okay? That's why we're starting small. We're starting with something that you know how to do and putting it in proof form. All right, so this is what you call a 2-column proof because you've got a column here and a column here. This column, the first column, is your statement. The second column is your reason. So why are you able to make that specific statement? Okay, so I'm gonna get rid of that stuff and we're gonna do this one. So if I start with 5x minus 12 equals 32 plus x, I am able to say 4x minus 12 equals 32. Well, what did I do? What allowed me to go from here to here? Whatever allowed me to do that is what goes on line 1. Well, you got to look at it. what did I do? I subtracted x from both sides. So that's the subtraction property. Now, at this point, I'm going to stop and talk about abbreviating. I'm allowed to abbreviate. I will allow you to abbreviate, but I need to be careful. I can't put SUB property here. Why? Well, there's two properties that start with SUB, subtraction and substitution. So if you're going to abbreviate, you got to make it very clear what you're saying. And I would go one more letter here and say subtraction property, SUBT, subtraction. Okay, continuing on with the proof. Okay, how do I go from 4x minus 12 to equals 32 to 4x equals 44? Well, I would add 12 to both sides, right? So what is the property being shown there? Well, I'm adding a number to both sides. It's the addition property. And then how do I go from 4x equals 44 to x equals 11? Well, I divide both sides by 4. What property is being done there? That's the division property. Again, notice I am not checking to see if you can solve an equation. That's not what I did there. I'm looking for the justification of each step. Now we're going to apply it to some geometry. A few more steps in this one. So let's justify each step. Okay, first thing I want to point out is this stuff right here. All right, the given and what you're trying to prove. The given is your hypothesis. The conclusion is what you're trying to prove. Talked about that at the beginning. Right? The given is like the hypothesis, and what we are trying to find is the conclusion. In other words, I'm going to replace if the hypothesis, so I'm going to replace the hypothesis with actually what we're doing here. If the measure of angle ABD equals 107, then the measure of angle ABC equals 66. We're going to try and prove that. So notice my first statement. A lot of times the hardest one is the first one. You might have to do the whole thing with nothing. So like all of this stuff that's given to you would be gone. However, for a little while, it won't be. So the statement is the measure of ABC, so that's this, plus the measure of CBD, that's this, equals the whole thing. Now we've talked about that one. Last unit. What is that called? If I add two angles together and that equals a whole angle, what's the angle addition postulate? So notice I'm using something from a previous unit. Those are fair game. Something from previous math classes, fair game for reasons for proofs. Okay, step 2. I'm telling you that I'm going to be using a substitution from step 1 to step 2. I'm going to be using substitution. That's what that says. Okay, what am I substituting? Well, what's ABC? I don't know that it's 66 yet. That's what we're trying to prove. I can't replace ABC with 66. Okay, what I can do is I can replace ABC with 4x plus 2 though, because that is in the picture. I can also replace CBD with 3x minus 7. That's also in the picture. I can also replace ABD with the given of 107. Because it's given, it's true, and I can use it. Okay, so that's my next statement. From 2 to 3, how do I go from 4x plus 2 plus 3x minus 7 equals 107 to 7x minus 5 equals 107? Well, I put 4x, 3x together to make 7x, and I put positive 2 and negative 7 together and made negative 5. So here's what a lot of people are going to say. They're going to say the addition property. That would be wrong, because the addition property says I'm adding something to both sides. I didn't do anything to the right-hand side. It's not the addition property. This is called simplifying or simplify. Yes, I did some actual adding, but it wasn't the addition property. The addition property says it's done. The addition is done to both sides. Okay, 4 and 5, I'm having you do these basically on your own at these couple steps. What would you do next? Well, you would add 5 to both sides, right? So add 5 to 107, you get 112. So what is that? The addition property. That one is the addition property because you are adding 5 to both sides. Then dividing by 7, you get 16. So x equals 16. That's the division property. Now notice there's still more steps. We found x though. We're done, right? No, that's not what we're trying to prove. We're trying to prove that ABC is 66. So what do I have to do? Well, I have to plug it back in. So I'm taking 16 and putting it in for x, which is what I'm showing here. So the measure of ABC, which is the one we're concerned with, is 4x plus 2, but I'm putting instead of 4x, I'm putting 4 times 16 plus 2. So I'm replacing x with 16. That is a substitution. If you're going to abbreviate it, SUBST would be substitution. Now, we already used that property. Are we allowed to use it again? Yes, we are. That's fine. And then the last step says, okay, what's 4 times 16? That's 64. 64 plus 2 is 66. And is that multiplication or is that addition? Well, hopefully you're catching on that it's neither. I didn't multiply both sides. I didn't add anything to both sides. All I did was simplify the right side. And look where we ended. The measure of ABC equals 66 degrees. Matches what we're trying to prove, meaning we are done. I know that was a lot. I know that was like, oh my goodness, I'm going to have to do that a lot. You'll get quick at it. I promise. Okay, notice how I want to make sure you catch this. Notice how the last step is what we are trying to prove. This is always going to be the case if you do it right. If you do it right, your last step is going to match what you're trying to prove. Okay, one more example, we're done. Suppose A, B, and C are collinear, so they're on the same line, and B is somewhere between A and C, okay? I gave you some information about AB. I gave you some information about BC. I gave you some information about AC. If you want to draw it, you can. I'm not going to, but you could. If you want to see what's going on here, you can do that. Notice I am not trying to figure out what x equals. I know that x equals 2. I'm trying to show how I get there. Well, I need to use the segment addition postulate to make my first statement. The segment addition postulate does not have any numbers in it. It has all letters in it. It says AB plus BC equals AC from the first lesson, or for the first unit. Now I am replacing AB with what I told you it was. I'm replacing BC with what I told you it was. I'm replacing AC with what I told you it was. That's the next statement. Well, how do I do that? How was I able to replace those things? Well, when I say replace, that should make you think substitution. Okay. Now what do? Well, I need to combine my like terms. So 2x minus x is x. 4 plus 15 is 19. So that would be not addition. I didn't add anything. All I did was simplify. I did add things, but I didn't add them to both sides. Last thing is I want to move 19 to the other side by subtracting it from both sides. That is the subtraction property. Okay. So that is your first exposure to proofs. All right. We'll do a lot more from here, but so you'll have a lot of chance to get caught up if that didn't make sense. So that's it.